Hello everyone. Sorry about the delay. It's not always easy being me when the VPN crashes in the middle of everything and you lose your connection. But I'm back now. Hopefully you're all ready to hear a bit about the new Fluid version, which I've been working on for the past 6 or so months. It's a major rewrite of everything. Pretty much all parts of Fluid have been rewritten from scratch to give you a much better experience, not just as a template editor, but also as a developer who needs to write, for example, view helpers. Um, First big question is why make Fluid 3.0? Well, the biggest reason is that we faced a couple of issues with the use of regular expressions that we had in versions 2.0 and earlier. And the problem with those regular expressions is that they're very sensitive to dependencies. So the libraries on the various systems would cause differences in parsing behavior in Fluid, and that's just not acceptable. So getting rid of the regular expressions dependency was the first aim. And we are completely free of regular expressions now. So there's another goal as well. That was a lot of conceptualization has happened in Type of Free community recently. And one of the most interesting developments is, I think it was Zeitgeist, who made a repository to have templates define their own arguments and to call your templates as if they were view helpers. So that was a very interesting idea, and that's now a native part of Fluid. So all of that works now, and you can have parameters for your templates. You can call your templates as if they were view helpers. So lots of things have changed. I won't cover everything that's changed in this stream, but I will explain a couple of very important differences. So the first very important difference is that we no longer have layouts or partials. These concepts just don't exist because there's no need for them anymore. So what we have instead is a way to extend templates. And when you extend a template, that's basically the same as saying this template uses this other template as layout. So that's the replacement for layout, is to extend another template. And this also means that we can get rid of these triple sets of paths. So no longer we have template root paths, partial root paths, and layout root paths. Instead, we have one set of paths, which is called an atoms path. And we refer to a template that exists within an atom path as an atom. And the reason we've chosen this word is there are design systems that use this terminology already, so it's good to piggyback on something that already uses the terminology. But another reason is atoms is a more unique word than, for example, a component or something. So when you search for Type of Free atom or Fluid atom, it should give you more appropriate results. So it's a short name, easy to refer to, already used by other parties. That's why we adopted it. An atom is just a template file. It can contain some parameters that you can use, which can be required, have types and so on, and sections, just like you'd normally create a template or a partial in the old terminology. So another benefit of this, not only do we have parameter support for templates, we also get documentation ability. So we can embed a description of a template inside the template file itself. We can embed usage examples where we can call this template, we can render it or give an example of how we would render it without actually causing it to be rendered. You can extend from other atoms as well, which will then inherit this documentation. So that when you, for example, render a full set of documentation for all your templates, it will inherit and give you argument definitions and so on. We also have a couple of new changes in the way of syntax. The most important one is that you can have numeric arrays by just using the square brackets, and you no longer need to define the keys. You can actually do the same with associative arrays, where you can use the ECMA literal shorthand, where you don't express the keys, you only pass an array of variables that then becomes associative. So I will show you a couple of examples in the code of how this works, and I'll focus mostly on the template writers task. So people who write templates will be interested in this. Let's see. This is a template from the new structure. As you can see, it has an extend clause as the first, and this refers to an atom called frame default that exists in a namespace called demo. We then have an embedded description of what this template file does, and then we have a small example here of how you would actually be using this component. Then we have the main section, which is rendered from this layout-like atom. So from here on out, everything that you're used to from Fluid is just the same. You render sections and you have your layout, which I can show you here, that contains the outer frame. So in this case, it contains the entire document because I don't have a framework around the rendering. And what this looks like when you render it is basically a known site structure. Layout is repeated for all of the pages, and the pages only define their individual main sections that cause a different output. In this case, like I mentioned, we have the embedded documentation, we have the examples in the template file, and we are able to extract those. I've made a little view here in the demo extension, which renders documentation for the atoms that are there. And just to show that it's the same approach, it's also rendering documentation for all the view helpers in Fluid itself, plus one from the demo package. When you view a documentation for this, it'll just contain what you're used to, the description, the arguments, but it also allows you to inspect the sections. In this case, no documentation is there for the section, but if we had documentation for a section, then it would be shown here as well. Then there's the syntax thing that I spoke about with numeric arrays. When you do that, it looks just like this. Easy enough to use, and you know it already from JavaScript. That's also how it works in PHP, so that should be familiar to you. If you need to use quoted values, then of course just put quotes in there and have a string or whatever. Then the examples, as mentioned, or the atoms, sorry. The atoms are registered in a namespace, which means that whenever you use this namespace, you're actually referring to a template file somewhere in that namespace. So in this case, I've registered the path here as my template, my atom path, and then we have within this path, for example, example columns, and that translates to a tag name like this. And then we pass the arguments, which in this case is defined in the template file. So we have an array of sizes for our columns, and we have a default value for it. And those are of course validated, so if you don't pass a required variable, you get a passing error that informs you in this specific place in the template. For example, if I make a mistake here and then view the right page, then I get an error that says you have an error in this specific file on that specific line. And yes, indeed I do. Back again. So this is how atoms work. Basically, you just use them as if you'd use a view helper, including if you'd want to use inline syntax. If I could learn to type, that would also work exactly the same. Then there's a tiny bit of information about some view helpers. For example, the fcomment view helper is now completely insensitive to all fluid code that you use inside it. So you can have as much and as broken fluid code as you want to inside the fcomment tag. It will be completely ignored and you won't see it in output. In fact, it doesn't even get passed. Yes, then a short explanation about the demo repository. I've created the repository in my own GitHub organization and called it Fluid Free Demo. So you should go here if you want to see these features. You just clone it and then Composer install it, and you can use PHP's local web server to run it. And what that demo contains is a description of the new concepts that we're using. It contains some documentation and important information about deprecations and removals and so on. And it contains examples of how you, for example, register atoms, how you declare the parameters, how you call your atom, and how it works in perspective from the old fluid version. So if you used layouts before, this demo site will also explain how you can use a layout style approach this time. It has some important information about the extending behavior. When you're extending an atom, then you are taking the sections and the body of that atom into the current atom, and that has some implications for inheritance. So you should be aware of that if you are going to be extending your atoms. Yes, it also explains how you do things like frender partial with section argument. So you can render a section from an atom like you would from a partial. It's just done a slightly different way in this new version. I will then show you the examples file that I made. This just shows you how to create an atom, how to use it, and how it works if you use it. So in this case, I created a special file that explains the examples, and then I made one atom that I'm just using for testing. This atom is just a template file that when you render it, renders two columns, a left and a right column, and which allows you to set the width of each, and of course also set a class name. Then I'm using this atom in a couple of different ways. The first way is just default rendering, where nothing is replaced from within the atom. This is the same as doing frender with a partial as argument. And that just causes it to render the entire file. So because this file has some output here, this is what will be output if you don't do anything else. Then I also did a rendering that sets some custom sizes and overrides the left and right sections that we have here. So by making these sections, we can have default outputs that we can have in our template. For example, in this case, we have this left, which means render the section called left, and the same for this right. So whenever we use this left in this template, it's gonna render from this section. But then if we overwrite the sections, it's not gonna render from the sections that are in the atom, it's gonna render this section instead. So by doing this, we can overwrite individual parts of our atom, just the tiny little part that we need to change. For example, if we only needed to change the right column, we could do it like this. And then there's another rendering here where we have a recursive usage. For example, columns inside columns is a semi-frequent use case, so that's also supported the same way. We have one outer column, a set of two columns, where we overwrite the left column inside that, and inside the left column we just have another default rendering of a two-column output. And when we render this, the first three examples I covered are here, You can see how that works. We have the default content coming from the the atom itself. Then we have our overridden values, and then we have the recursive rendering, where I've also set a custom class for the text, just to make it a bit bigger. And then there's one more way you can use it. By using fextend, you can extend an atom inside a section. So in this case, I've created a section that's called columns, which I would like, when we render this section, I would like it to behave like the columns atom, but I wanted to do something else. I wanted to require a new argument, or I wanted to make some additional output. So what I did here is just define the section, have the fextend in there somewhere, which means import everything that's coming from this atom, the sections, the documentation, and the output nodes. So before we use the fextend, I place the title, and that means the title comes before what we are importing from the atom. If we had done this, then our header would instead be below the default output of this atom. And then I declared one more parameter, a title that we like to render in the header, and then I made that a mandatory argument. So that means that when I want to call my special version here that additionally also renders a title that's required, I can use this columns and pass it the title. And that causes the same rendering that you've seen with the columns, except it has the H1 title in front of it. So that's how that works. Those are the most important parts of Fluid 3.0. Let's just give you the full face. Those were the most important parts. So there are a lot more new features, especially if you're a developer. There's a lot of changes in the internal View Helper API to make it smaller, not to make it bigger. So you will need to get accustomed by just reading the source code, and there will be some more extended docs. And of course the demo site also explains a bit about how to do that. It has examples for how you write a view helper in the new practice. And of course all the view helpers that are shipped within Fluid all conform to this new practice. So those are good places to study. Yes, I think I'll take some questions. If anyone has questions, feel free to type them in the chat, or mention me on Twitter, or write it on Slack, and I'll reply to it here. Yes, so Sebastian Michaelsen writes, what's the oldest version that will be compatible with Fluid 3.0? That's a very good question. My plan is to get it into the next version after LTS, the next LTS. So we're probably speaking about version 11 because it is so breaking. But because it's also a library and we have the type of free core using the sub-package split now, we could in theory create a replacement Fluid system extension package that would override whichever one ships with type of free, and would maybe be able to support both versions, both usages, or only support the new Fluid 3.0 version. I've already taken a look at most of the classes and templates that are in the type of free core in version 9.5 LTS, and they are almost compatible. It takes very little work to make them compatible. The view helpers take a bit more work and may require some class replacements, but it should be possible to do this. It should be possible to provide you with Fluid 3.0 support right down to type of free 8.7. Yep, Björn says fextend is my most favorite feature as a frequent Twig user. Great. Yeah, thanks Björn. Mine as well, exactly because it solves the same purpose as layouts did before, and allows you to do other interesting things with your templates. One thing I forgot to mention about fextend is that you can extend things that extend things that extend things, and so on, and incrementally you only replace smaller or different parts. So you can have an extended atom that consists of sections from 3 different template files where you only override 1 or 2 of them in the final atom. Let's see if we have maybe questions on Twitter. Yeah, we have a complaint about the breakdown in the start. Sorry about that again. Yeah. I think that's all the questions. Anyone else? Last minute questions? Alright, then I will finish the stream now. It will be available as a recorded stream, so you can always come back to this URL and watch it there. I think I'll also take a look at uploading it to YouTube, so we can get it spread a bit more with the embeds and so on. So thanks everyone for watching. I really look forward to giving you the new Fluid 3.0 version, and I can't wait to hear what you think about using it in production. So thanks everyone, and talk to you again another time.